We're going to look at section 3.4, composition of functions. We have two functions, f of x equals 3x plus 2 and g of x equals negative 4x minus 1. And we want to find this new function, f composed of g of x. Now, it looks like it says fog, but that little circle is just the composition symbol. And what this means is that we are going to take f of x, and the input into f is going to be the function g of x. So we're going to take, and instead of plugging in an x to f of x, we are going to plug in what g of x is, negative 4x minus 1. So we replace x in f of x with negative 4x minus 1. So we're going to have 3 times negative 4x minus 1, and then we've got the plus 2. So we can distribute the 3, we get negative 12x minus 3 plus 2. Combining those constant terms, we get negative 12x minus 1. We can go the other direction as well. We can make g be the outside function and f the inside function. So that would be g composed with f of x. Okay, so here we're going to take g of, and then for x we plug in f, 3x plus 2. Take negative 4 times, then plug in 3x plus 2, and then we have a minus 1. Distributing, we get negative 12x minus 8 minus 1, so our resulting function is negative 12x minus 9. All right, let's look at another example. We're going to take f of x equals x squared minus 1, and g of x is square root of x. Let's find f composed with g of x. Okay, so we're taking f and we're making g the input. So we're going to take f and we're have x squared, so we're going to put in a square root of x, and then f tells us to square it, and then we've got a minus 1. If we square a square root, that undoes the square root, so we end up with just x minus 1. Okay, let's go the other way. Now let's find g composed with f of x. So g is now on the outside and f is going on the inside. The square root of, and then plugging in f of x for x, we get the square root of x squared minus 1. All right, so that's our new function. Now let's look at using a table of values for x and function values of f and function values of g to determine composition of functions at given values of x. So let's take g composed with f of 2. Okay, so this is going to be with g as the outside function, f is the inside function, and we're actually plugging in a value of 2 for x. So first thing we do is we evaluate f of 2. Well, from the table we see when x is 2, f of x, or f of 2, is equal to 6. So we replace f of 2 with what it's equal to, 6. And now we use the table to determine what g is when x is 6. And we can see that when x is 6, g of 6 is 7. Okay, let's try f composed of g of 4. So now f is on the outside, g is on the inside, and we're plugging in a 4 to g. So first thing is we will evaluate g of 4. So here's 4, g of 4 is 6. So this, we replace that g of 4 with 6, so this becomes f of 6. F of 6, here's 6, and f is 2, so our result is 2. Now let's look at g composed with itself of 6. Alright, so now g is on the outside and it's on the inside, so we're going to be using g 2 times. X is 6. Alright, so if we plug in a 6 for g, then we get function value of 7, so we replace that inside g of 6 with 7, so this becomes g of 7. Well, we don't have x equal to 7 at all in our table. Alright, so this does not exist. There is no function value for g when x is 7. So we can either say it does not exist or undefined, either way.